Hey everyone, I'm Christopher McGinnis, and today we will be talking about regression parameters. I know the flyer is a little goofy, but the concept of regression parameters is extremely important in engineering analysis. Regression parameters are estimates of the unknown population parameters and describe the relationship between a predictor variable and a response. This is a typical regression parameter. There are 10 different types of regressions. We'll be focusing on logistic regression parameters for our example. With logistic regression, we only need a binary response, such as a pass or fail. In this table, we see motorcycle speed ratings and load indexes. For my case, I will typically only weigh 145 pounds, with a slight fluctuation depending on how big my lunch was. Looking at that, I can keep my load index the same, and then only care about how fast I will typically go, and possible max speed if I attend a track day at Jennings GP. So, with this, for a logistic regression, we can keep one variable, such as the load index, the same, and then you look at the speed rating and determine if we want a faster or slower tire. Based off this handy-dandy little table I made up, we can see that this would be a typical logistic regression. Some of these values can be explained by maybe having low tire pressure at certain speeds and capture points of data. These data points are made up, but if you applied a logistic regression parameter, you'd see a typical normal distribution, and this would look fairly similar to what a regression would look like on tire failure. This would prevent things such as tire blowout at high speed or tire blowout due to low tire pressure. This is an example of tire blowout due to high speed on the freeway. One of the reasons why we use logistic regression is to hopefully, as engineers, negate our product from doing this, or possibly if we're testing technologies, we know that there's a failure point to what we will be doing, and we don't hit that failure point, or we at least expect that failure point. So when estimating regression parameters, we need to know how our data type will be impacted, and can we reasonably reduce variables without affecting end goal product successes, such as a tire can reach a speed of X with a load of Y based on our tests. Thank you.